Above ground, the Chihuahuan Desert in Mexico is a dry, rocky expanse. It's an arid landscape where water is extremely scarce and the heat bakes the surface. But in April 2000, silver miners drilling 980 feet down punctured a limestone wall and stumbled into a hidden fault chamber. Inside, they found a chaotic forest of translucent selenite pillars. These crystals are massive, some stretching 37 feet long and weighing an estimated 12 tons, jutting across the room at sharp, intersecting angles. There was an immediate catch to exploring this cavern. The air inside the chamber sits at a superheated 136 degrees Fahrenheit, wrapped in 99% humidity. That combination creates a lethal wet bulb environment. Because the air is entirely saturated with moisture, human sweat cannot evaporate. Your body loses its only mechanism to cool down, meaning an unprotected person will succumb to heat stroke and die in about 10 minutes. The only reason anyone could step inside at all was because industrial pumps for the nearby mining operations were constantly draining the groundwater away. That artificial dry spell started a fleeting, ticking clock on our ability to study the cavern. In 2006, a scientific team led by crystallographer Paulo Forti arrived at Naica. They knew the mine wouldn't operate forever, and once the pump stopped, the water would return, so they had a rapidly closing window to extract data. To bypass the total failure of human biology in a wet bulb environment, they invented custom refrigerated gear called the Tolomea suit. These caving overalls were lined with refrigerating tubes connected to a 44-pound backpack loaded with ice and cold water. To protect their lungs from the scorching moisture, they used a specialized cold-breathing respirator. Even wrapped in the most advanced survival technology available, the melting ice only bought the scientists about 30 minutes of life at a time, turning their research expeditions into a series of desperate sprints. The primary question driving these short bursts of research was geological. What exact set of rare conditions allowed gypsum crystals to grow to the size of school buses? This diagram illustrates the cavern's subterranean heating system. Miles below the fault line, a magma chamber radiated intense heat upward, boiling a pocket of groundwater saturated with sulfide ions. Cool, oxygenated surface water eventually seeped down to meet this heated layer. Because of the density difference, the two waters never mixed. Instead, the oxygen slowly diffused across the boundary, oxidizing the sulfides into sulfates. Over time, the overall temperature of the water dropped. The moment it dipped below 56 degrees Celsius, it triggered an ultra-slow crystallization process. That chemical state held steady for 500,000 years. The resulting 12-ton pillars are the direct, fragile byproduct of a 500,000-year perfect thermal equilibrium. While geologists mapped the structures, geomicrobiologist Penelope Boston arrived hunting for ancient fluids trapped completely inside the solid rocks. To get those samples without contaminating them, her team employed a meticulous aseptic drilling process, driving small boreholes deep into the core of the massive selenite structures. Within the tiny fluid inclusions encased in the calcium sulfate matrix, they discovered extremophile bacteria that had been dormant since the cavern's formation. Using sterile methods, researchers were able to extract and reanimate these microbes. When sequenced, their DNA didn't closely match anything in our known genetic databases. The cavern proved to be a perfectly sealed biological time capsule, preserving extreme, unmapped life forms right alongside its geological structures. The 15 years of human access came with a steep physical cost. The oxygen-rich air that allowed scientists to observe and document the cavern was slowly causing with selenite to deteriorate. That brief window of exposure reached its defined limit in October 2015. The overlying mining operations officially ceased, ending the financial incentive to keep the deep tunnels dry. The massive industrial water pumps that acted as the cavern's lifeline to the surface were shut down. Without the pumps running, the mineral-rich groundwater naturally surged back into the fault. The chamber refilled entirely, submerging the crystals in total darkness. Our period of access was an artificial 15-year anomaly in a million-year geological timeline. To ensure the crystals survive, the cavern had to be willingly surrendered back to the earth.